So the next talk, in the next 30 minutes, we will learn from Elliott Ash how to build a robot judge. Elliott is an assistant professor here at ETH for law, economics, and data science. Yes, so he's an expert on the topic, and take it away.
Thank you. Thanks everyone for coming, and thanks for everyone at home to join in, and thank you for the kind introduction. Happy to talk today about building a robot judge, and I'll try to motivate the topic a little bit and talk about two research projects that I've been working on that are looking at some of the building blocks for a robot judge. I also teach a course in the fall. It's we're about to have the fourth lecture on Monday that's called Building a Robot Judge, Data Science for Decision Making. So if some of the material in this presentation is interesting to you, I recommend you take a look at that course. We'll be teaching it again next year. So the first question is, what's the matter with human decision making? Why do we need to have a robot judge making decisions in the first place? And it's not really hard to find examples of humans making problematic decisions. One of my favorite examples in the case of the law is this recent paper from Israeli bail courts, where they looked at how often the judges put defendants in jail before or after their lunch break. And it turns out that after breakfast, they give these kind decisions where most people get let go and they get off. Right before lunch, everyone is being put in jail. After the lunch break, the judges, they're not hungry anymore, they're feeling more refreshed, and they let people out again. And then towards the afternoon, after the afternoon snack, you see the same thing. So this is one nice example of a robot judge is not going to get tired and hungry, right? So more seriously than that, there's well-documented disparities in the legal system. This is not just because of judges, but for some disparate decision-making and disparate treatment, disparate outcomes at many levels in the legal system, criminal justice system, and across different groups. You see these historical inequities. And I think there's a hope that if we bring in some more algorithmic decision-making, it might be easier to detect biases and mitigate them. So how about robot decision making? What can we say about it so far in this new world of artificial intelligence? So, there's a lot of hype, of course, a lot of companies that are coming in and trying to say, we're going to have a robot lawyer, we're going to have a judicial chatbot, and I think that this hype is often maybe a little too much. We're often see in the news a lot of promises about predictive policing. You can imagine, like, the police for a long time have been building data on where crime occurs and trying to use target policing to follow these predictive models. We also see just as many articles showing the problems with predictive policing systems and showing they could actually amplify there could be somewhat small biases in policing at the beginning of the introduction of a system, and then those could be amplified. I won't talk about this issue too much in the talk today, but I'm happy to talk about it in the Q&A because I think it's a really important and interesting issue. So more generally, we're seeing right now this revolution in data science, artificial intelligence, and I think there's a lot of promise for this to help us support human decision-making. You can imagine having a robot judge and a human judge teaming up like we have here. And we can also use a lot of these technologies to better understand human decision-making. And so I'll show you examples of both today. So in particular, I like to, when I say kind of data science for decision-making or data science for analyzing the law, I think of that having two pieces. So the first is this more perhaps more classic approach to social science or analyzing legal system, and that's trying to get a kind of causal factors or doing a causal inference at the determinants of decision making. And I'll show you an example of how we do that in the case of how news media influence judges. And then secondly, this is kind of the more new area of data science for decision making, which is using artificial intelligence, machine learning, to predict decisions and provide advice to judges. And I'll show you an example of how we're doing that to detect corruption using budget data in Brazil. So this is the outline of my talk. today, in terms of looking at the effect of tough on crime media on judges, I'll be looking at the case of Fox News Channel. I think that this is a United States cable news channel, but I think it's actually kind of pretty familiar the world over now. I know that on my VIScon box, we actually have Fox News Channel, so you can watch it here. But I'm not sure how many people in Switzerland would be interested in doing that, but at least in the US, it's a very popular network, but it also has a very politically conservative reputation, kind of supporting Donald Trump in many of the conservative policies that the Republican Party has been pursuing. In particular, they talk about crime, the issue of criminals and crime, in a very different way on Fox News relative to other cable news networks. So if you, I won't get into the natural language processing technicalities in today's paper, but that's something that we explore in the class, and something that my research group does a lot of. We trained word embeddings on the transcripts from Fox News and CNN, and looked at the words and phrases that were closest to crime. And you can see that just from looking at the sets of words and phrases that tend to show up around crime in Fox News, you can see this very different discourse, even almost like a racialized aspect to it. Whereas in CNN, you see teenagers or alibi, kind of like more just standard criminality type language. So we saw this and we're like, well, is this difference in discourse associated with differences when judges or other people in the legal system are exposed to Fox News? So we have data on criminal sentencing in the United States. These are from local county courts from 2005 to 2014. It has some very rich information on sentencing, and we wanted to ask if the judges watched Fox News more, or if their constituents watch Fox News more, are they tougher on crime? Does that change their criminal justice decision making? And so our empirical specification is, this is kind of a standard linear regression model that you would use to analyze this question. In economics or econometrics or the applied social sciences, you'll see this all the time, where our outcome is the length of the sentence, and then capital T is our measure of Fox News viewership. It's just the average viewer share, how often people watch Fox News in that local county, and then we have some controls. So the problem with just estimating this equation is that if you just ran this regression just to compare counties that had more Fox News viewership and more or less criminal sentencing harshness, it might not be due to Fox News. It might be due to some omitted variable, or in the computer science literature, they might more likely to be called a confounder. That in particular, the more conservative counties that watch more Fox News, they also would tend to have tougher judges. And you might also get responses to higher crime rates where people watch Fox News, and reverse causality. So how are we going to address these, what we would call endogeneity concerns? It's a strategy that is well known in econometrics called instrumental variables. So the way this works is, if you have a variable, what you would call an instrument, that is correlated with the treatment variable or explanatory variable of interest, but isn't otherwise related to the outcome, you can use this for causal inference. So in particular, this is a institutional peculiarity in the United States where across different counties, you have these different cable systems, and the lineup or the channel positioning across networks is different across different localities. And this is different in Europe, where you can actually choose the channel numbers for the different networks, but in the United States you can't. And it means that in some areas, Fox News is like number 20, and in other areas, Fox News is number 80. And you can imagine that when you turn the TV on, it starts off at number 1, number 2, and then you're looking for news, and you just start channel surfing up the number list, and then you settle on the lowest numbered channel. And it turns out that that we didn't invent this, but this Martin and Yurikoglu paper from a few years ago found that you can use this channel position as an instrument because it makes people watch Fox News more. But it is otherwise, it's as good as random. It's like flipping a coin and making people watch more Fox News. So This is great from an empirical standpoint. So we can look at the places where Fox is a lower channel position. Do judges respond differently in their criminal justice decision making? And so this is just some of the technicalities. We run the first stage, but this tells the whole story. Depending on the number that Fox News channel has, between 20 and 70, you see this decrease in the viewership. So as you get higher in the channel number, people watch it less. And so we're identifying variation in the criminal justice system due to this channel position instrumented exposure to Fox News. And it turns out it has an effect. So this is just I'll show you a couple of regression tables. I know these are a lot of numbers, but I'll also say it in words. Variation in Fox News viewership due to the channel position increases the harshness of sentencing given by judges in those local county courts. And you can see this in our baseline specification when adding a bunch of controls for the types of case, so it's not driven by different types of cases. You can also see it when you look at comparing Fox News relative to the other cable news networks, MSNBC or CNN. Neither of those networks have an effect. It really is a Fox News-driven, tough-on-crime effect of news media on judicial decision-making. So just to try to understand this, what's happening a little more, we looked at a few possible mechanisms. First, we know that it's not due to legislation. So because we're looking at counties within the state, we're holding the criminal laws constant, and we're comparing judges in the same state that are making decisions about the same laws. So we know it's not due to the legislation channel. We also found evidence that it's not due to policing or prosecutors, so we didn't find kind of more arrests or more policing. We didn't find differences in crime rates. We didn't find that the prosecutors were giving more charges or harsher charges. So that leaves the judicial channel. And the way that we tried to verify that is to look comparing elected judges to appointed judges. This is kind of an interesting institutional aspect in the United States where the USA and Switzerland, I think, are the only two countries that have elected judges. And you'll see that in the case of the United States, the judicial elections result in this kind of tough-on-crime mentality from news, making it into criminal justice decision-making. But you should realize that elections for judges in the United States are totally different than how they are in Switzerland. In the United States, you see these, I should have put some of these in the slides, but you can Google it. They have these crazy ads where they're like, oh, I'm the toughest on crime judge on earth. I'm going to put him away for 100 years. Whereas in Switzerland, the ads are like, I went to a good law school and got good grades. So it's a very different political system. And from the perspective of social science, it's nice because in some states they are appointed, in some states they are elected. So what we did is we just ran our analysis separately for the elected judges and appointed judges, and you can see for the appointed judges there's no effect of Fox News. But for the elected judges, there's a big effect that goes in the same direction that we saw earlier. And also we found that within Kansas, some judges are elected and some are appointed within the same state, and you see the effect for elected judges and not appointed judges. So overall, suggesting that this partisan media effect of tough on crime is due to influencing voters, and then judges respond to the tough on crime attitudes of their constituents. So we also wanted to understand, was this affecting different types of defendants differently? And part of the motivation here is we looked at we compared areas with different Fox News exposure to the instrument to their Google Trends. And so the first thing we found is that there's not really a difference in how concerned people are with crime as evidenced by Google Trends, but it does have an effect on the use of racial slurs. So when we produce data on the number of racial slurs that people are Googling about, and in the places where people watch more Fox News due to the channel position, there's more racist Googling. So we suspected there might be a variation in how judges are treating different defendants in response to this. So In particular, our effect is totally concentrated among black race defendants, African American defendants. And so this is a very kind of concerning mechanisms that we can see. There's no difference in the treatment of Hispanic or female defendants. Consistent with this kind of orientation towards a kind of disparity in treatment towards black race defendants, we saw an especially large effect for drug-related crimes. And so this is, I advise you to read about this. It's a very long and concerning history about drug crimes being used as a pretext to convict black people of felonies. And we find some evidence that Fox News Channel, this kind of conservative media apparatus, plays an important role in that. Meanwhile, for DUI, which is driving under the influence, so alcohol, driving while drinking alcohol, there's no effect on that. And then finally, just to kind of draw all the links as much as we can, we looked at survey data about is crime an important problem, and we actually don't see an effect there. This is survey data from Gallup. But if you ask people, are drugs or crimes related to drugs the most important problem, we see an effect. So it seems like Fox News is influencing people by making people think that illegal drugs are a bigger problem. And we see that reflected in the criminal justice outcomes as well. So that was the first building block of kind of looking at kind of causal factors of decision making. You can see there's many ways where this would be useful for judges who are making decisions about cases or policymakers who are deciding about how to design the judicial system. The second thing I wanted to show you guys is how machine learning could be used to support judging, or in this case, anti-corruption policymaking. This is easy to motivate. Corruption is a huge problem. If you added tax evasion to this list, I think Switzerland would come out at a higher rank, but now it doesn't. So our goals are to predict fiscal corruption based on public finance accounts, and we have this really great data set for doing that in Brazil, where we have information in all of the local public accounts from different cities in Brazil, as well as some audits, some randomly assigned audits where they searched for corruption. And what we're able to do is train a machine learning algorithm based on the public finance accounts to predict what the audit decision will be. Is it corrupt or not? We'll actually use that to extend some empirical analysis of corruption. So this is kind of how machine learning can support analysis of corruption policy. And then third, we're going to use the predictions to simulate these counterfactual policies, where if instead of doing random audits, we did targeted audits based on machine learning, how much more corruption could we detect? As I mentioned, the institutional context is Brazil, where we have about 5,000 municipalities, and they have this central role in public good provision. And in 2003, the Brazil government, this is like, a stereotype that there's a lot of corruption in Brazil. They recognize it, and they introduced this really amazing anti-corruption program where there's random assignment of audits to different cities. And these audits have a very good reputation in the sense that they were implemented by this independent federal agency. A team of 10 to 15 auditors would come to the city and then pore over the books for a few weeks and then figure out how much corruption is going on. So basically, they send a team of 10 to 15 auditors to go over all the books. We have a computer or machine learning algorithm just look at the numbers as a whole and detect whether corruption is present. And we'll see that the machine learning algorithm can do that pretty well. So the audit data is, I'll just skip this. We have data on the audits. We have data on the municipality budgets. It's about 800 variables, so you couldn't use standard linear regression models to do this. We need to use machine learning. We use a gradient boosting classifier. If you've taken a applied machine learning course or kind of learned about this on your own, you might be familiar with this model called XGBoost, which is short for extreme gradient boosting. This is just a nice, kind of optimized Python package. It's also available in R for doing classification or regression tasks using high-dimensional structured data sets. And there's now a number of papers showing that just as a starting point, use XGBoost, you'll get good performance in most machine learning tasks. So we take the standard steps you would do in an applied machine learning project, where we shuffle into a training set and test set, tune hyperparameters in the training set using cross-validation, and then the metrics that I'll show you are from a held-out test set that the model hasn't seen. So this is what it looks like. We can detect the presence of corruption with 75% accuracy. The AUC, I think, is even more informative. This is what matters, this line, about 0.8, 0.82. That's kind of on par with other papers in this literature that have tried to use machine learning to support, for example, judge decision-making about recidivism. And we also just have, as comparison, using OLS, like a standard kind of just like linear regression without any kind of penalty, and it's not that much better than guessing. So we have some additional figures showing that the machine learning model accurately distinguish corrupt municipalities from non-corrupt municipalities. It also can rank them quite accurately by their risk of being corrupt. So this means that, for example, if we just bin the municipalities by their corruption risk, so if our model says that the municipalities in this group, they have about an 80% chance of being corrupt, it turns out that about 80% of that bin of municipalities are corrupt, according to the true audit data in the test set. So in order to kind of break, this is XGBoost is similar to other machine learning models in the sense that it's kind of a black box. You give it a high dimensional data set and it gives you some predictions, but it's hard to know what it's doing in the meantime. We wanted to understand what features it was using so we could actually understand, is it using corruption relevant factors in the budget versus something that it does not seem corruption related, in which case maybe our model is picking up on some correlated factors. These won't be that interesting to you, but if you understood kind of the corruption literature in Brazil, some of these items would jump out at you. It turns out that previous kind of qualitative research on corruption in Brazil and other developing countries has focused on investments and other items that our model identifies as important for machine learning, predicting corruption. And another thing we did is we also scraped all of the audit reports. So these come in PDF from the Brazilian website. We did some simple NLP pre-processing and analysis on them, and we just counted the number of times that the budget features in our data set were mentioned in the reports. And then we regressed the number of times a budget item was mentioned in the reports against how much our machine learning model says it's a pivotal feature. And we see those are actually quite positively correlated. So it means that our model independently identifies budget factors that turn out to be mentioned in the audit reports that it's never seen. This gives us some additional confidence that we're detecting corruption relevant factors. So once we have this data set, once we have this machine learning model, we can then build a data set with it by predicting, given a set of budget accounts data from a municipality in a given year, how likely is corruption happening in that municipality. And then we can use that for starters, to extend existing empirical analyses. Previously, if you were trying to look at what causes corruption or what are the impacts of the detection of corruption, you could only use the relatively small number of municipalities that were audited. But now we can use all 5,500 municipalities to do that. And we're able to replicate an existing study showing that when there's government transfers to a local municipality, that increases corruption. And we can show that using our just the predicted values for corruption risk from our machine learning model. In addition, we wanted to look at the effect of the being audited on the presence of corruption, because this is an important policy relevant question. Is hopefully when you audit a city, it actually reduces corruption in the subsequent years. Who knows? Maybe they reduce corruption only in the year after, and then it comes back soon. Thank you. And that was impossible to do previously because they can't audit the municipalities over and over again every year. But we can use our budget predicted corruption risk data point to see, does corruption go down, does it stay down? And so this is what it looks like. In the places that are audited, this is the predicted corruption probability based on our algorithm. So you can see that there's no effect beforehand, and then after being audited, it goes down significantly. And so this is our predicted corruption risk. This makes good sense, right? Like if the places are audited, corruption goes away. Most interestingly, I think, is to compare the municipalities where corruption was found versus the one where they said that it was not corrupt. And you can see there's this big difference. The light gray lines here are where there was no corruption detected, and you can see there's no effect. But in the places where there was corruption detected, the black lines, you see this big decrease in predicted corruption. And if anything, it's going down more like 5 years later. So this means that the kind of the deterrent or the enforcement effects of these audits is lasting for a little while, which I think is helpful to know. So just one more point I wanted to make about how machine learning can support policy making, in this case, audit policy. We wanted to say, compare a new policy that used our machine learning predictions to say who should be audited. And so this is the current system of random audits. They find corruption about half the time. And so these are, there's a lot of audits that go forward that don't find anything, and arguably that's wasted effort. One question would be, what if we audit the municipalities based on their predicted corruption risk from our algorithm? And so remember that we can rank the municipalities by their predicted corruption risk, and then if we can audit 178 municipalities per year, let's just choose these top 178 based on their corruption probability, right? And so what would happen if you implemented this policy? It turns out you'd have very high corruption detection rates of about 98%. Basically, all but 2 of the audits that you make would detect corruption. And so this is a much higher success rate given that audits are an expensive process and you can only do so many of them per year. So if you just compare the policies, you increase the number of detections by over double, and you could achieve the same number of detections as the status quo with only 84 audits. And so if you're a corruption agency director, you might want to implement this policy to conserve on resources. And also it increases deterrence, of course. So just to skip over some of these additional issues, I think that something that's potentially interesting is, what is going to be the incentive effect of these policies? Because once you start introducing an algorithm for detecting corruption, the municipalities or the mayors who could be engaging in corruption are going to try to game the system, right? They're going to try to learn what the algorithm detects and move towards corrupt activities that the algorithm cannot detect. And so this is something that in the future, when policymakers try to adopt these types of algorithm-supported policies, they'll have to deal with this. And similarly, there's kind of this open question about how much information about the audits, the audit policies to publicize. Because if you just say this is what the model uses, it's going to be easy to game. But if you don't give any information, then people will engage in a lot of potentially costly gaming behavior. And then in the longer run, to make this work the best, it would be ideal if we had a mixed system of random audits like we currently have. Those could be used to continue to update the algorithm over time as people change their behavior. But then we could use the targeted audits to maximize corruption detection and to increase deterrence. So just to recap from the 2 sections of these building blocks for a robot judge that I've been discussing, The first is how to analyze causal determinants of decisions. We showed how to do that in the case of news media and judge decision-making in criminal justice cases. And then second, there's a question or a goal of supporting effective decision-making using machine learning, and we showed how to do that in the case of budget data. And I think that more generally, these two building blocks of causal inference and machine learning are going to provide these important tools for using data science to support decision-making, not just in the law, but also other areas such as medicine. And thank you. Meeting adjourned.
Thank you very much for this interesting talk. We would proceed with the Q&A. As a reminder, for those watching online, you can ask questions over Slido, and they will be asked on your behalf by our signal angel. And until we have one, we will continue with questions in the room.
Yeah.
Thank you. One question about the first part. Have you ever saved data from the Republican judges versus the Democrats? And have you seen a difference?
Interesting. Actually, I don't think we looked at that, partly because this data isn't available for most of the counties that we looked at. The effects that I showed you, it's likely driven by two factors where Republican judges are more likely to be voted in because it affects voting, but also it's likely that even within Republican judges, within the set of different Republicans or Democrats, it also pushes them in a given direction. But interesting thing to check. Thank you.
Any more questions?
Have you tried, or are you planning on trying to apply these methods that you just showed with the example in Brazil to other countries or to corporate financial, situations or,
Yes, interesting. Yes, it's something that we've considered. It turns out that Puerto Rico and Colombia both have actually similar systems. We haven't gotten the data for that, but I think that our system or our approach could be applied in a number of contexts. Something else we were thinking about is to look at kind of corporate fraud type contexts. In the United States, at least, there's many corporate misbehavior type cases every year, and you could imagine building a data set from public accounts like CompuStat, like these information, these data sets on securities, but also looking at the text of their filings to the Securities and Exchange Commission. So it's something we've thought about. I think it would be very exciting and interesting to do. One limitation on that, especially in the case of the companies, is that it's not randomly assigned which companies get investigated. So there's already this very complicated selection process of who gets a case and then which cases are published. So it's something that it would be a bit more complicated to do that, but I like that idea.
Thank you. Any more questions?
Could you use the robot as a kind of like a policeman to overview all the cases?
Interesting. I think that's a hope, or that's one of the promises of this technology, right? Is that the example of the anti-corruption policy is that we could use these kind of corruption risk predictions as we could then maybe warn the mayors, right? And say, oh, by the way, according to our algorithm, it looks like there might be some suspicious activity in your town. Maybe you should reconsider it. And that actually might be, effective enough for them to reduce corruption even before actual audits are performed or actual policing actions. It's something that we've discussed. I'm not sure if we'll do it. Is basically form these predictions for recent years in Brazilian municipalities, and then email the mayors or contact them and say, oh, we have this information on this corruption risk. But I think that would be a very controversial policy, at least for us to do. But I think more generally, like if you can try to apply these types of technologies to predictive policing or decision making in criminal justice cases, there is an argument for supporting human decision making just to kind of maybe help break ties or to help people focus in the right direction. Thank you.
Thank you. We have time for 2 more questions. There's already one.
So as a follow-up to what you just said, if you don't actually email these mayors, what do you usually do with the research?
Yeah. So we publish it in journals, and then if mayors or policymakers would be interested in using this technology, we would help them use it. That hasn't happened yet. There are these conferences of mayors and kind of like AI for policy type, sort of like conferences or nonprofit agencies that try to implement these types of projects, like the World Bank. So this is still a bit preliminary; it's not published yet. But at some point, we would hope to implement that.
All right, and a last question. Well, if there are no more questions, then also not from the internet? Well, in that case, I would like to thank you very much for coming to VIScon Digital with an exclusive VIScon Digital mug.
Fantastic.
Some chocolate.
Great.
Yeah, thank you very much for coming out.
Thank you, everyone.